Here's lesson 9 on absolute value and step functions. We're kind of coming to the end here of our linear functions unit. And these are two very different kind of linear functions. We call these two linear functions piecewise linear functions. The absolute value function and step function are both related to linear functions. They're special types of linear functions called piecewise linear functions. The reason they're called piecewise is because they are made up of pieces. Okay, a piecewise linear function is any linear function made up of more than one line, but it still satisfies the definition of a function. In other words, it's going to pass that vertical line test. Or in terms of a function, it still has exactly one output for every input. So everything in the domain maps to exactly one element in the range. Okay, so what we'll see here is the absolute value function first. Let's take a look. We're going to look at graphing an absolute value function. I know this is something we've kind of already seen this year, but let's see exactly what's going on and why this would be considered a piecewise linear function. Okay, the first thing we want to do is we want to look at our function. It is g of x equals the absolute value of x plus 1. Remember, that's what those bars mean up here. The x plus 1 is between these bars. That means absolute value. So we are first going to find g of 4 and g of negative 5. Well, what does that mean? Remember, we just take g of 4, so our function, and everywhere where I saw an x before, I'm now going to put in my 4. So I have the absolute value of 4 plus 1. So g of 4, in other words, my function evaluated at 4, equals the absolute value of 5. And the absolute value of 5, what is that asking me? That says, how far away is 5 from 0 on a number line? And the answer there is 5. It is 5 units. Let's try g of negative 5 now. G of negative 5. Okay, again, anywhere I see the x, I'm now going to put in a negative 5. So g of negative 5 is going to be the absolute value of negative 5. Come on, negative 5 plus 1. So I have negative 5 plus 1. Let's see. So g of negative 5 equals negative 5 plus 1 is negative 4. So the absolute value of negative 4. And again, what we have to say to ourselves here is how far away is negative 4 from 0? And that is 4 units. Okay, it doesn't matter if we go left or right, right? It doesn't matter. It just matters how far away. A distance is always positive. So the absolute value of negative 4 is simply 4. I'm sorry, yes, 4. So g of negative 5 equals 4. So what does this mean for us? Well, remember, these are points. Okay, so up here, when x was 4, my y value is 5. Okay, that's how this reads. What is x, or when x is 4, what is y? Y is 5. Here again, when x is negative 5, that's what this says, what is this function evaluate to? It evaluates to 4. Okay, so we have points. This point here would be negative 5, comma, 4. And the one above would be 4, comma, 5. When x is 4, y is 5. When x is negative 5, y is 4. Let's take a look at this completing the table piece here. Okay, first I'm going to write in the function. So the function is absolute value of x plus 1. So now when I plug in numbers, I know what's going on. So I say that, let's see, I have the absolute value. I plug in negative 3 for x, so negative 3 plus 1. Negative 3 plus 1 is negative 2. And the absolute value of negative 2, how far is negative 2 away from 0? It is exactly 2 units. Let's try negative 2. So the absolute value of negative 2 plus 1, again, I just stuck negative 2 in for x. So negative 2 plus 1 is negative 1. The absolute value of negative 1 is 1. Once again, negative 1 plus 1, so that says 0. The absolute value of 0 is 0. Let's plug 0 in. 0 plus 1. That tells me positive 1, and the absolute value of positive 1 is 1. 1 is 1 unit away from 0. Keep going here. 1 plus 1. That's going to say the absolute value of 2, which is 2 units away. Here I have 2 plus 1, which is 3. The absolute value of 3 is 3. And here I have 3 plus 1, and the absolute value, that's the absolute value of 4, and the absolute value of 4 is 4. So, now I have coordinates. I have an x, and I have a y value. Okay? Remember, this g of x, or f of x, or p of t, or whatever it happens to be, the function notation, is the same thing as saying y. Okay? So I have coordinates. Let me start graphing these coordinates. So let me go, the first points here, negative 3, 2. So 1, 2, 3. Remember, this is my x-axis, and this is my y-axis. Okay? Put some arrows on here. So going 1, 2, 3, negative 3, and then up 2 gives me a point. Going 1, 2, negative 2, up 1 gives me a point. Going negative 1 and up 0 gives me a point. Going over 0 and up 1 gives me another point. Over 0, up 1. Okay, so look at what's happening already. I can tell that this is not going to be linear, right? Because there's no way I could draw a straight line that goes through these. All right, let me keep going. So I go over 1, up 2, over 2, up 3, and over 3, up 4. But what I do happen to see here is that I do have some points that are kind of in a straight line. Like these red ones are in a straight line going in this direction. So let me do this. And these blue ones are kind of in a straight line going in this direction. So I'll do that. Put my arrow on the end. And if you notice, I have two pieces here now. I have two lines, the blue line and the red line, and they make our V, remember, for absolute value. That's how absolute value functions always graph the letter V. And we have these two pieces. All right, so let's take a look at, so this is why we call it a piecewise linear function. It is two lines that make one function. Okay, this does not violate any of the rules of a function. So what is the minimum value of the function on this interval? Well, let's see. The minimum value of the function here is going to be the lowest y value. Okay, so the lowest y value, if we look, is going to be here. This point. Okay, that's the minimum. It comes down, hits that, and bounces back up. And the y value at that point is 0. So the minimum value of the function on this interval is 0. Now it says, over what domain interval is the function increasing? Okay. So we have to know a little bit of our vocab here. Remember, the word domain, whenever we see that word, it refers to the set of all x values. So we're looking from left to right. That's my x values, right? From this axis here, going from left to right. So I want to know on what interval, so what piece, that's what an interval is, from where to where is my function increasing? Okay, well, let me start here with this blue line. As I go this way, reading on the x-axis, does this increase or decrease? And it clearly is going down. That's decreasing. So again, I'm going to keep reading from left to right on the x-axis, again, my domain, and I finally get to here, and it says it's all of a sudden this is going up. So from this point all the way to forever, this function is going to be increasing. So when we ask for the interval that this is increasing on, it would be from what is this x value that's actually circled in green. That is the x value -1. So x is increasing from -1 all the way to infinity. So actually from -1 is less than or equal to x, because that's the beginning. X is between these two spots, and infinity. So on this interval, this function is increasing. Okay? The way you look at this, remember, is just x is in between these spots. So everything in between the lowest part and the highest part, going from left to right. So -1 to infinity. All right, let's take a look at something else. Let's try to just evaluate an absolute value function. Okay, that just means like solve kind of algebraically and see what's going on. So this first one, here's our function, f of x equals the absolute value of x plus 3 minus 4. So we want to find f of 4. So I have f of 4 equals the absolute value of 4 plus 3 minus 4. Now remember, parentheses and the absolute value bars work the exact same way as parentheses. So I want to figure out everything inside those absolute value bars first. Okay, so I still have this f of 4 equals, and inside here I'm going to add those together. So the absolute value of 7 minus 4. Now, I want to apply the absolute value function and determine what is the absolute value of 7 before I continue. Well, lucky for us, the absolute value of 7 is simply 7. So the absolute value of 7 is 7. I'm going to replace that with just 7, and I still have this minus 4 on the outside. So I didn't just drop the absolute value bars. I took the absolute value of 7, and I got 7. So f of 4 equals 7 minus 4. So f of 4 equals 3. And what does this mean for me? Well, this means when x is 4, y is 3. So I have a point 4, 3 that would be on this graph. All right, let's try this -5. So f of -5. So we're going to do the same thing. F of -5 equals the absolute value of -5 plus 3 minus 4. So f of -5 equals -2 minus 4. Once again, I get to this point and I'm going to take the absolute value of -2. So I still have f of -5 equals the absolute value of -2, which is -2 is how far away from 0? It is 2 units. So I replace this absolute value of -2 with what it is. It is 2 minus 4. Now I have f of -5 equals 2 minus 4, which is -2. So my point here, this reads, this function evaluated at -5 equals -2. So when x is -5, y is -2. So the point here would be -5, -2. Okay, and that's all you have to do to evaluate these. But now we're seeing that when we evaluate a function, we are always getting a point out of it. These points, -5, -2, and 4, 3, lie on these lines, this piecewise function. Okay, so let's look at the last thing here, step functions. And we're going to do a little bit more with this in class tomorrow. But I definitely want to go through how to kind of see what a step function is. You'll realize in the end here exactly where it gets its name from. It's going to look like a set of steps. Okay. Some neat things about step functions are they're usually given to us in pieces. So here's the two pieces that we have. This just says, the way you read this is, the function f of x equals 2 when I put in the numbers from 0 all the way up to, but not including, -5. It also says f of x equals 6 when I put in a value for 5 all the way up to and including 10. So there's really only going to be two outcomes, two y values, if you will, for all of the x values from 0 to 10. All right, so let's take a look. When f equals 0, so I'm sorry, not f equals 0, f of 0. So when x is 0, what is this function? Well, let's come back up here. So f of 0, well, that lies in this part of the domain, and it tells me my y value must be 2. Whenever I fall in this part of the domain, the answer is going to be 2. So f of 0 is going to be 2. Okay, let's look at f of 2. So when x is 2, I fall in, again, in this piece. 2 is between 0 and 5, which means my solution, my y value, must be 2. And that's all we have to do. Here's probably the trickiest one. Well, let's skip f of 5. Let's go to f of 7 here. So f of 7, when x is 7, so f of 7, let's find which interval. Oh, 7 is not between 0 and 5. 7 is between 5 and 10. So that means my solution must be 6. Let's look at 4. When x is 4, so f of x, so when f of 4, does it fall between 0 and 5? Yes, it does. 4 is between 0 and 5, which means my answer must be 2. And lastly, well, I guess second to last, f of 10. Okay, so I look and I see that f of 10, I find it is not between 0 and 5. It is between 5 and 10 included. So I must have 6. Let's go back to this 5 one now. Okay, when x is 5, okay, so f of 5, let's look here. Okay, so between 0 and not including 5, right? This does not say or equal to 5. So it's not in the set. 5 does not belong here. Now look down here. Oh, 5 is less than or equal to. So 5 is included in this set here. So this is what we're going to look at. So 5 is in this domain, and therefore the solution is 6. So now let's graph this. What are these? Well, these are, remember, these are x's and y's. So let me show you some points. This point would be 0, 2. This point would be 2, 2. Down here I would have 4, 2. This would say 5, 6. Remember, x, y. 7, 6. And 10, 6. So again, when I put in a 10, I get a 6. When I put in a 7, I get a 6. Okay, that's how this is read. That's how this reads. The x values always are independent. It's what we can put in. When I put in an x, I get out a y. I put in a 7, I get out a 6. Put in an x, get out a y. All right, let's graph these. So I have the point 0, 2. Over 0 up 2. That is a point right here. I have the point 2, 2. Go over 2, go up 2. I have the point, so I just did this one and this one. Let me do this one. Over 4, 1, 2, 3, 4, and up 2. Okay. I also have, let's see, over 5, up 6. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. Over 7, up 6. And over 10, up 6. All right, so I've now graphed all of these points. Again, when we look at these now, we can see that this is definitely not linear. Okay, it's definitely not one line. However, this is a piecewise linear function because we do have multiple lines, and it does not violate the terms of a function. So let's think about what's going on here. I want to start this whole thing is going to be graphed from 0 to 10 and nothing else. So there's not going to be arrows going left or right. So from 0 to 10 is where this function is going to be graphed. So when x is 0, that's right here. I already have a closed dot there. That's perfect. Remember, that's what I need, is a closed dot. Now, I'm going along this way, and just because my point stops there doesn't mean my line necessarily is, but I'm going to stop there for 1 second. Now, I'm going to look at this top part. This says when 5 is less than or equal to x, which is less than or equal to 10, and I'm going to graph from 5 going over to 10. Now what ends up happening here is I can keep going towards x equals 5, but remember, I can't reach it, I can't touch it, so we use that open dot. By having that open dot there tells me that there's only one spot on the function at this point, and I am good to go. Alright, that's it for step functions and absolute value. I will see you all tomorrow.